Worksheet 7, finding my compositions, also the domain of f, the domain of g, and the domain of the composition function. Well, finding the domain of the composition function can be a little bit tricky, so we're going to do that all along the way. First, I'm going to find both the domain and the range of each of my individual functions. Since the parent function for f of x is the square root function, it is shifted left by 9 units. The domain of my function f of x will also have shifted left. Since the domain of the parent is between 0 and infinity, this one shifted left 9 units will be negative 9 to infinity. And since my range is not affected, it will be equivalent to the range of my parent function, which is from 0 to infinity. For g of x, since the parent function for g of x is actually x squared, this is the quadratic function, it will share the same domain and range as that function, which is between all real numbers, so between negative infinity to infinity, all real numbers, and its range, when I square something, it's only positive numbers, so it'll be between 0 and infinity. Okay, now I'm going to consider the domain of my compositions. F composed with g of x, which is equivalent to f of g of x, and g composed with f of x is equal to g of f of x. Let's look at the first one. Its domain are all of the possible values of x I could plug in here. Well, first I'm taking this x and I'm plugging it in for g. So looking at g, I can plug in any value for x. So far so good. Out of g, I get only values that are between 0 and infinity. I'm then taking those values for g of x and plugging them in to f of x. Since all of my values for g of x will go into my domain for f of x, any number I plug into g will be able to plug into f. So my domain is just all the numbers I can plug into g, which is negative infinity to infinity. My domain for g composed with f, let's take a look at that one. Do that one in red. This domain for f. Well, the first value of x I have, I plug into f of x. So I'm starting with values of x between negative 9 and infinity. So already I have a restriction. Values of x in this function have to be greater than or equal to negative 9. Out of that, I get values in the range of f, which are between 0 and infinity, and I plug those values in to my function g. So those values go into the range for g. All of my values in this range will fit into this domain, so I don't have any further restrictions. So the only restrictions in my domain is x has to be greater than negative 9, and goes on forever. Once I have those domains, I'm going to go ahead and find what these composition functions actually are. For my first one, I take the value of g of x, and I plug it in for f of x. That will be the square root of x squared plus 9. Now, a common error, or something that students tend to do, will be that to equate this to the square root of x squared plus the square root of 9. This is a big no-no. Don't do that. Unfortunately, because of the order of operations, these two are linked. X squared and plus 9 are linked as a single term. So this is as simple as this will get. This would be a big mistake. Looking at my second one, I'm going to take this value of f of x, square root of x plus 9, plug it into my g of x. So it's the square root of x plus 9 squared. My square root cancel each other out, and I'm left with just x plus 9. This is why we looked at the domains separately. From the looks of this final function, it may appear that all real numbers would plug in. However, the domain tells us that this function, this composition, only works for values of x between negative 9 and infinity. Let's take a look at the second one. Here again, I'm going to look at my domains and ranges. The domain for my first function would be whenever it is undefined, whenever I don't have an undefined value. You can also think of it in terms of its parent function. My domain here would only be undefined when x squared minus 1 equals 0. Well, that only happens when x squared equals 1, or when x equals plus or minus 1, when I take the square roots of both sides. That would mean that x cannot equal positive or negative 1 in this domain. So my domain really is all values of x that are not equal to plus or minus 1. Okay. The range, it's helpful to think of its parent function, which is 1 over x, which has a range of values, f of x not equal to 0. So here I don't have any shifts up or down, so my range will be exactly the same. F of x cannot be 0. So I can get any number out of this with the exception of 0. And looking to g of x, I can pull, this is a linear function. My domain for linear functions are all real numbers. So between negative infinity and infinity. You can also equivalently label this as all real numbers, or for all values of x. Those are 3 equivalent ways of writing all real numbers as a domain. And my output or my range is also all real numbers. Now I'm going to find my compositions. F composes with g of x, which is f of g of x, and g of f of x, which is g evaluated at f of x. My domain for the first one will be all of my values of x that I can plug into g. So g's domain, all real numbers. From that I get out all real numbers, which I then plug into the domain for f of x. Well, now here I have a problem, because I cannot plug all real numbers into f of x. There are restrictions. Specifically, I cannot plug in values of g of x, which are equal to 1, or values of g of x, which are equal to negative 1. Since g of x is the values I'm plugging in for f of x, I cannot plug in when g of x equals the positive portion of this, or when g of x equals the negative portion of this. So to figure out the values of x where this happens, I'm going to replace g of x with its equivalent form. So x plus 1 equals 1, and x plus 1 equals negative 1 would give me undefined values in this composition. Well, this happens when x equals 0 and when x equals negative 2. So my domain, or the restrictions for values of x in which I can plug into my composition f of g, would be when x is 0, so x cannot equal 0, and when x is negative 2, so x cannot equal negative 2. There's my domain. Now I'm going to find the domain for my second function. Those would be values of x, domain, values of x that I plug into f of x, so I cannot plug in plus or minus 1. I already have that restriction. Out of that, I get values of f of x which are not equal to 0, and from those I can plug any of those numbers into my function g of x. So my only restrictions is the restrictions I started with, which is x cannot be plus or minus 1. Now I'm going to find this composition, so I'm going to take g of 3 over x squared minus 1, which is 3 over x squared minus 1 plus 1, which when I combine with the least common denominator is 3 over x squared minus 1 plus x squared minus 1 over x squared minus 1, which turns out to be x squared plus 2 over x squared minus 1. Also, I should probably go ahead and find my first composition, since I skipped that. Here I'm taking the value f of g of x, which is x plus 1, and plugging that into my value function for f, which gives me 3 over x plus 1 quantity squared minus 1, which equals 3 over x squared plus 2x plus 1 minus 1, which equals 3 over x squared plus 2x. There's my two compositions, their domains, as well as the domains of my original functions.